So today I'm going over the video on siding relationships, the triangle inequality theorem, and the Pythagorean theorem. So first off, we're going to go through the side angle relationship. This picture demonstrates that idea because the idea of the side angle relationship is that this side is related to the angle across from it. Okay, so this angle opens up to this side over here. So the side angle relationship is the fact that this angle relates to this side. You can see that in this picture. Okay, so this 14 degree opens up to a 2.234, and sorry, 2.34, and then this bigger angle opens up to a much bigger side, which is 6.63. I can make that even more exaggerated, right? So as the angle gets bigger over here, so does the side that relates to it. And here we can see as the angle gets smaller, so does that side that relates to it. Okay. This can be applied to a triangle also. So we can notice the smallest angle here opens up to the smallest side. So we have a 36, a 56, and an 88. Okay, so the 36 is the smallest. It goes to the 5.5, which is the smallest out of the 5, the 9, and the 7. Okay. Likewise, it also relates the largest angle goes to the largest side, and then the medium angle goes to the medium side. And you can see that even if we change the shape of the triangle, that still applies. So the smallest angle here is 15, and it points to the smallest side, which is 2.7 compared to the other two here. The largest angle is 138, and it opens up to the largest side, which is 7. Okay, so as I make this smaller and smaller and smaller, you can see eventually this becomes the smallest angle. So now this has to be the smallest side. Okay, and notice the 7's smaller than the 11's. Okay. Now that it's the biggest angle, this has to be the biggest side. So that's 4 and that's 3. So this one has to be the biggest side. Cool. So that's the side angle relationship. Okay, there's some applications of that. But first, we want to make sure we understand how to label it. So as we said, this angle opens up to the side across from it, which is right here. And so we label it the angle with a capital A and then the side with the lowercase a. Okay, this angle opens up to the side over here, which would be the lowercase b, and this angle opens up to the side over here, which would be the lowercase c. Okay, so that's demonstrating the side angle relationship. It's a lot sloppier than just showing one, but that's how it works inside of a triangle. Okay, so some side effects are, in this triangle, we can see it's an isosceles. These two angles are these two sides are the same. And you'll notice the orange side relates to the orange angle over here. Once again, they're opposite each other. These are related. And then this is related to that. Notice the 66 in both of them. So not only is the small related to the small and the large related to the large, if the angles are the same, then so are the sides across from them. Okay, notice that the one across from the 48 is not the same. It's different because it has a different angle. Okay, so for instance, these little tick marks mean that those sides are the same. So this side is the same length as this one over here. So that means the corresponding angle has to be the same on both of them. So 52 would be on the bottom right. Okay. We can also see the same effect happening with an equilateral triangle when all three sides are the same. That means that all three angles have to be the same. Unless there's only one way for that to happen, and that's if the angles are all 60 degrees. Okay, so all three sides are the same, all corresponding angles are the same. Okay, so that's a side effect of the side angle relationship. Okay, so once again, the idea is that this angle and relates to the side across from it where that arrow is pointing. Hopefully you see my mouse. Okay, so next one is this triangle inequality theorem. So I like to call it T-Rex arms. The third side of a triangle has to be between the sum and the difference of the other two sides. So sum is when you add, and then the difference is when you subtract the other two sides. Otherwise, it's not going to reach. So notice the two little arms there won't connect to actually make a triangle. Okay, so for instance, this one, there's nowhere that I can drag it to be able to reach 25 units. It's too far, right? So together they end up having to at least add to the longest side, which is 25. Otherwise, they're not going to work, right? These right here, and if I add them up, the 10 and the 15, we get 25. So this is smaller than that. And if I subtract them, we get 5. So this one should make a triangle because 17 is between when I subtract them, which is 5, and when I add them, which is 25. So they should be reasonable to connect here. Cool. So it's not perfect, but it looks like it's going to make a nice connection there. This one, on the other hand, the 20 and the 5, if I add them up, I get 25. So 10 is less than that, which is good. But if I subtract them, we get 15. So it has to be in between 15 and 25, and 10 will be too small. You'll see that there's no way that I can connect them because there's still that big distance between them. It's not going to be able to connect. This would be an instance of T-Rex arms. Okay. So this one's important. What if they are exactly the same size? So 6 plus 9 is actually equal to 15. And so it looks like it's going to make it. But what we really get is just two straight lines that are on top of each other. And two straight lines on top of each other are not triangles. Okay, it's hard to see because it's not letting me zoom in. Sorry about that. So two straight lines, if they add up equal to that third side, it's not going to work. Okay, so when it adds up, they have to be less than. If you subtract them, it has to be greater than, because subtracting gives you a smaller number and adding gets you a bigger number. Okay. So that's the triangle inequality theorem, that the third side of a triangle has to be between the sum and the difference of the other two sides. Otherwise, it's not going to make it. It's not going to reach. Okay, last idea is the Pythagorean theorem. We're applying the side angle relationship here, that the 90-degree angle corresponds to the largest angle in the triangle. Okay, and we call that the hypotenuse. And the hypotenuse squared is always equal to the square of the other two sides. So if you add a squared plus b squared, you're going to get c squared. Okay, so I have one example for this. We'll go see that. Okay, so what I've had you guys do is I identify the 90-degree angle, otherwise this Pythagorean theorem is not going to work. I'm going to do the side angle relationship to show me where side C will be. And then A and B are interchangeable, so I'm just going to label them like that. The idea is that A squared plus B squared is equal to C squared. And in this, we chose A to be 10, and then B, we don't know, and then C would be 115, or sorry, 15 squared. Finish things up. Sorry, it's a little bit sloppy. What is it? 225, I believe. I should use a calculator. Let's check that really quick. I don't have these memorized. 25. Okay, and then when I subtract that, when I subtract that, we end up with b squared is equal to 125. Okay, we can type that in this space, SQRT of 125, and then the approximation. So 11.18, and that one it took. So notice if it says to round, it wants you to round. If it doesn't, then you can put the exact answer, which is generally more appreciated. Okay, so that was the Pythagorean theorem, that the side across from the 90 squared is equal to the other two sides squared added together. Okay. So we stated the side angle relationship, which is that the angle opens up to the side across from it. The triangle inequality theorem, which is the third side of a triangle, has to be between the sum and the difference of the other two sides. Otherwise, it's not going to reach, kind of like the poor dinosaur here that can't reach the toilet paper. And then the last one is the Pythagorean theorem, okay, that the one across from the 90, so that's the side angle relationship to find that, is equal to the square of the other two sides, okay? So the one across from 90 squared is equal to a squared plus the b squared, the other two sides squared and added together. Thank you.